Ajay the Scholar presents Math 0400 Introduction to Mathematics Chapter 1 Logic Section 1.1 Propositions and logical connectives of one proposition, namely negation. Thank you very much for listening to this introduction. Now on to the main video. Hello there. Like it says here, I'm RJ the Scholar, and let's get learning. The announcer just said that we're talking about logic, namely propositions and logical connectives of one proposition, we're going to talk about negation. Yeah, the title's a bit of a mouthful, but I think it gets the point across. And that's what's important. So, you may be wondering, why are we doing logic in a math course? Isn't that English or science or philosophy or something? Come on, don't introduce logic into our mathematics. We can have math without logic. Well, it's because math isn't about numbers in its entirety. Math's about more than numbers. And logic is the way that we make mathematical arguments. That things are true. We use logic to argue that things are true. And we probably use it in something like to prove that x plus 5 equals 10 has x equals 5 as a solution. We obviously substitute 5 into it and logically reason through it. Now, when I talk about it, logic, you may be thinking, oh, I know logic. You may. But I'm assuming that you don't. I'm assuming that you only know how to think logically, like critical thinking, but you do not know symbolic logic that I'm going to teach you now. And with the computation-heavy math you've been used to, like calculus, trig, algebra, stuff like that, you're probably not used to proofs. And unless you've taken a geometry class where they made you do 2-column proofs. But those are kind of lame, and you really don't do them in math. So, we're gonna teach you how to do proofs. Essentially argue that a mathematical statement is true, and be able to rigorously say it. No one's gonna be able to poke holes in your argument. And that's what we have to hope for, because if we have the ability to poke holes in your argument, then your argument is about as mathematical as a double cheeseburger. It's not. It's basically, your argument could be salvaged, of course, but your argument is flimsy at best, like a floppy disk. And you could probably break it easily. And then all the things you've done, you'd have to reformulate it, prove that. If you have more errors, if everything's based on that, you would have to prove that again in hopes of the rest of it being true. Because if that's not correct, if the proof's not correct, we don't know if the statement you made is true. And if we don't know that, then we're going to start panicking. And no one wants to start panicking Do we? No. So that's why we have to learn logic to create rigorous proofs. And this course will introduce you to this side of mathematics called pure math. And will hopefully teach you enough that you're able to learn more. This is gonna be not so basic, but it's gonna be nice, and it's gonna open your eyes. There's a period in life before you know mathematical logic, and there's a period in your life after you know mathematical logic and pure math. I'm going to hopefully get you over that transition. So let's get started. Okay, here we go. Okay, so I've written down this on the board so we won't have to spend time me writing down everything. But we're going to do our first definition. A proposition is a statement that is true or false, but not both. So, I think it's illustrative to do an example. So which of the following are propositions? Is this a proposition? A cat. Just the phrase, a cat. Leopards are cool. Is that a proposition? Why, Jim? Is that a proposition? Go here. Is that a proposition? The sun is a star. Is that a proposition? Unicorns exist. Is that a proposition? And x plus 2 equals 4. Is that a proposition? Now, what I want you to do is pause the video now. Enter in your results in your comments, including your justifications, if you need one. And I'll give you 5 seconds to pause the video, and then I'll go on with the solutions. 5, 4, 3, 2, 1, 0. Okay, now. It's time to do it. So, statement. A cat. Is that a proposition? I picked up the red chalk. You know what this means. No. See? The universe agrees with me. A cat is not a proposition. It's not even a full sentence. How can it be a proposition? How could it be a statement? It's not stating anything. It's just a cat. It's just word salad. Doesn't mean anything. Just a noun. Nouns aren't propositions. Sadly enough. They have to be full statements. So that gives us our first red X. Yes, there are more. So the statement, leopards are cool. Leopards are cool. So, that's a statement, but is it true or false? Let me ask you this. What is cool? Can you define cool? Is cool something that you like? Well, some people think leopards aren't cool. It's not a universal truth. So, sadly, even though I personally might think that it is true, it's not a proposition. Okie dokie. Why Jim? Now, it's not a statement, it's a question. Questions can't be propositions. Neither can be commands like go here. So, the rest of these are going to be some upsets. We're 0 for 4 on propositions. So let's see if there's a proposition here. The sun is a star. That is most definitely a proposition because it's a true statement. Yeah! A check mark. Finally, a check mark. Unicorns exist. We might not know the truth value of it. It's false. But it's still a proposition. Doesn't matter if we don't know the truth value of it. If it's a true or false thing, it is a proposition. So, we give it our green check mark. And finally, x plus 2 equals 4. Let me ask you this. What is x? It could be true if x is 2, but if it's not 2, then it's false. And if it's false or true, it can't be both. It can't be conditionally on x because propositions don't account for conditions. It's true or false, but not both. So sadly, I'm going to have to give this one I know. Not all mathematical ideas are propositions. In fact, that's something we have to rectify later. But as you can see, these are some examples of propositions. Now, I'm going to write down another example, but it's going to be off screen. So, yeah. So, here is the next example. Yeah, the next example. Ooh, spooky. So, what are the truth value of the following propositions? What is the truth value of the following proposition? I messed up with grammar. But grammar shouldn't let you stop because I'm not a grammar police. So, what I mean by truth value is whether it is true or false. So, the truth value of a true statement is true, and the truth value of a false statement is false. Just a way of assigning true or false to something. So, we'll denote true by the truth value T, and false by the truth value F. And we'll be working with these from now on, because they're a lot easier to work with. And they're more general. And that's a topic we'll be doing more with. We love generalization. So, is 1 plus 1 equal to true? Come on, you can tell me. You can tell me. It's true? It's true? You've been like, it's basic mathematics? Come on. I did Scala. Come on. Yeah, it's true. The square root of 2 is a rational number. I will tell you right now that it is not. If you didn't know that, you might need to review some algebra or math in general. Because at the base level we're working with is, you know this. And so, is a bee a plant? Can you tell me if a bee is a plant? Bzz, bzz. I'm a bee. I'm a plant. No bee ever says that. Okay? No bee ever says that. So we gotta give that an X. No matter what. Not even if a bee shows up at my door with a loaded gun and says, I'm a plant. Yeah. It's false. I'm sure of it. And moving on. There exists a real number x such that x squared is -1. There isn't. Yep, there is not. Sorry. It's just that only a complex number could square to -1. So I'm not complex enough to believe that. So I'm not going to do that. Okay? Okay. Good? Good. Better? Better. Okay. We did it all. We're done with these. Okay. Now we'll actually do stuff with these propositions. We'll do things with them. And those things we'll do are called logical connectives. See you on the next board. Okie dokie! So, what's this up here? Yeah, I think I remember talking about actually doing stuff. And this is the first of a doing stuff we'll be doing. So, what is the negation of P? It's denoted by this symbol, not P. It's pronounced not P. So, the negation of P, denoted by this backtick, P, I call it not P. People say backtick P. Some people use tilde, too. But it's true when P is false, and false otherwise. So, it's pretty simple. For example, we have Jimmy is alive. The negation of that is Jimmy is dead. That's morbid. But there's some ambiguity there. I could spin it, but it's not going to be fun. For a more mathematical example, the negation of 2 plus 2 equals 5 is 2 plus 2 is not equal 5. And it's denoted by putting a little backtick before here and surrounding it with parentheses. But that's a negation. And since 2 plus 2 equals 5 is false, 2 plus 2 not equal 5 is, drumroll please, true. Color me surprised. So, we kind of have our idea. Negation is just negation. It's saying the opposite. I'm the opposite man. So, let's take a look at their truth values. We're going to paying attention to those truth values because it's useful for deriving truth. If we have one thing that's true, we want to reason about its negation. We want to be able to reason about whether its opposite is true and what that implies. So, we're going to construct a truth table to denote the relationship between P and not P. So we have on our left the input, and there's two possible inputs, so we list every one of them. And on the other side we have the outputs. And it just follows logically. if P is true, then not P is false because P is not false. And if P is false, then not P is true. Now, you could also kind of find a relation, a double negation relation. Like, you'd be able to see that, well, not P is this. And they look the same. So, they're what we call logically equivalent. Though we'll talk about that more in a few lectures. So yeah, that's all about negation. Next time, we're going to talk about the two logical connectives of two propositions. Binary logical connectives. Ooh, binary. Everyone loves binary. I love binary. I'm a computer scientist. But yeah, this is the end of the video and the first lecture. And I just have a few messages for you guys. Remember to like, comment, and subscribe to RJ the Scholar. Also ring the bell, because YouTubers say to do that, and I just gotta copy them. Also, I have a message for each and every one of you. I want each and every one of you to have a great day, have fun, learn lots, and as always, keep learning. RJ the Scholar, done with his first ever lecture. See ya.